moving hopefully very quickly. So Yassine, I need your full focus, and it will be based on yesterday algorithm. Please take all the notes, okay? So my question to you is like this. So read question to yourselves, and according to the first step of the algorithm, tell me what do we have to optimize. So read the question and tell me what do we have to optimize.
The maximum area of the rectangle that can be inscribed inside of the semicircle.
Okay, so we're optimizing what? Area, right?
Yes.
The area of the rectangle. In particular, we are looking for maximum. Okay, good. Now, at this point, the questions like this, they require a diagram, okay? Read the question again and tell me, what is special about the rectangle? Check and tell me what do we know about the rectangle?
It's inside a semicircle with a radius of 10.
So it's inscribed, okay? Now, I will have to stop and talk more about inscribed shapes, because in grade 10, 11, and 12, we didn't do it. I don't know if you were doing this before. So I have to make sure, because some questions are like this, that you understand what's inscribed. Is there anyone who knows what's inscribed shape? Well, if a shape is inscribed inside another shape, what kind of conditions should be met? Okay, if not, let's do like this.
It's not larger than the shape, but it's inscribed.
Okay, but still it's very vague. So I want first, you understand? It's what?
It's inside. It's like
yes, of
here
course,
the question,
inscribed.
the rectangle is inside the semicircle.
Okay, so I'll do this through examples. You understand that I stepped a little bit away from the question because I'm focused on the term inscribed. So Yassine will tell me now, if I have a triangle like this and a square like this, is it inscribed or not inside the triangle?
Yes.
It is inscribed. Any other opinions?
No.
No opinions. Okay, then keep thinking. If I sketch the same triangle and the shape.
Yes, this one's inscribed, the other one isn't.
So this one is inscribed, the other one is not. Why? What's the difference? Yassine, please remove the mobile phone and work with me. So what's the difference between between this shape and this shape?
This is
More?
only fits it.
So, or using the terminology of math.
Inscribed?
What can you say about the vertices of the inscribed shape?
They're touching all.
They are touching the sides, yes. So basically, this is the definition. This is how we know if it's inscribed or not. So the vertices of the shape have to touch the sides of the outer shape, okay? So this is inscribed, this is not inscribed, okay? So based on this, and it can be any shape, right, theoretically. So for example, here, we know that the rectangle is inscribed inside a semicircle. And it's inscribed in a way which is different than general definition of inscribed. Why? There is a condition. Tell me what kind of condition is there in the question which determines how the shape is inscribed.
It says the length of the rectangle.
So the length has to be along the diameter, exactly. So don't think about units yet. You have to figure out what's your diagram. So I am going to place only the semicircle, and you will take now 30 seconds to inscribe the rectangle in your notes according to the condition here. More will do it on the board. And Yassine as well. Yassine on the board and more on the board. So please inscribe the rectangle inside the semicircle according to the conditions of the question. And then we will check. It looks like a square more, right? Could you be, right? It has to be a rectangle. I know, but I want to see it. I want to see a rectangle, not a square.
It has to be exactly with the diameter. Very good.
It says, I mean, think about it. How is it possible?
I got it. That's really much.
Okay. Okay. Yes. Okay. Thank you. Yes. So I said it's not a traditional, but semicircle. So it touches the semicircle, right? Because it's not the entire circle. But if it was in the entire circle, then the four vertices should touch the circumference. But here it's a semicircle. That's why the rectangle and actually my shape, I will do it intentionally different than most probably your shape is. So that you understand that there are a lot of options to inscribe it.
This is how I do it.
So for example, I decided to go for a rectangle which has got a very big length and very short width. Okay? But this is inscribed according to the conditions of the question where the length has to be along the diameter. Okay? So now we have the diagram. We know that we are we are optimizing the area, right, of this rectangle. Can you please take notes? Okay. So we are going to optimize the area of this rectangle. And as you guys, Yassine's rectangle was a bit different than Mo's rectangle, right? And different than mine. So you understand that there are options out there, right? So depending on the dimension. So I'm also going to solve this question differently than the way we solved it in the first period. So and I post both solutions so that you can compare if you have time. Right. I want to complete the diagram because there is more given in the question. Read the question again and tell me what else can we add to the diagram in terms of the dimensions of the shapes. Radius of... Okay. Okay, so the radius, let's speak about the radius first because this is what's given, right? So this segment, and this is the center of the circle, right? So this segment is 10. Now, my question for you is, how about this segment, which might be less obvious to you? What is the length of this segment? 10. It's also radius. Do you see that? And this is what we're going to use in this solution. So this is also 10. Why it's important? You will see eventually. So it will help us to model. Now I want to ask you last question before we start following the algorithm. What can you say about the length of this segment? Don't be in a hurry. And this segment. What do you think? They are the same. They are the same. This is important, okay? So now the diagram is there. We know that what we are optimizing. My question is, what is the second step? Modeling, okay? So we're going to model the area. The area of what? Which shape you see? Model the area of the rectangle. Mo had a good sleep, right? Yes. But this is much better than yesterday. So model the area equation, okay? So if I'm going to model the area of the rectangle, what's the first thing I should think about? That it's length times width, absolutely. Because if I'm modeling in one of the questions, a triangle area, I will think about the formula related to the area of the triangle, which is different, right? Yes. So, so the area of the rectangle, you can use R or you can use shape, doesn't really matter. I decided to go for the symbol instead, it's fine. And I am saying that I know that the area is length times width. Guys online, can you hear me? Are you with me?
Yes.
Yeah.
Great. So the area is length times width. If I know that the area is length times width, what do you think I'm going to do now?
The same thing with this.
This is not, give me a...
We're going to assign like a variable.
So we're going to first determine what should be the variable, right?
Yes.
And then determine the variable. And then express both dimensions in terms of the variable, right? Violet, do you agree? Express both dimensions, in terms of the variable. Okay, your suggestions. What do you think we can give the? Let's go for x, right, as a variable. So what do you think we should? Let's try width, right? No, width. No, it will be much easier if it's not width. So think about another option. The length of what? Okay, so eventually we are going to work with this triangle. I'm giving you the clue that eventually
There's no triangle.
are you sure?
Oh, that one.
We are going to use this triangle. We will work with this triangle. So if we are going to base, why with this triangle, do you think?
Because you can find the.
Because we have already one of its sides, it's 10. We also can see what type of triangle is it?
Right angle triangle.
It's a right angle triangle, so this gives us a lot of comfort. Okay, so so again, my question again, based on what we have just discussed, what do you think should be the x variable should stand for from these shapes? If it's not the width, because I'm saying that the width of the rectangle, it will be harder, the equation.
Half length.
Half length,
Half baseline.
which means, and this half length, what will it become for this triangle? One of the legs, right? So let me choose a color which will be visible. So, because everything is green here, so I'll go for X and X. So you see this segment, which is at the same time one of the legs in the triangle, and when you have a shape inside the shape, try to split them. So I'm going to take this triangle out so that there is you are not confused, okay? So just to confirm that you understand what happened. So this is 10 and this is X, okay? Okay, I would like you to do it as an extra practice on your own and then tell me the derivative, okay? Guys, do it now in your notebooks and tell me the derivative. 3 minutes.
What, miss?
Yeah?
Can't I distribute the 2x at the beginning?
Of course you can distribute it. Why you cannot distribute it, Noor?
No, I'm just asking.
No, yes, and I'm asking too. Why can't you distribute it? What's the obstacle for distributing it? Guys, who sees the power? Noor, power of half does not allow you to distribute 2x. Okay? Guys, can you hear me? Noor, did you hear me?
Yes.
Yes,
Yes.
Okay. So once you are ready with the derivative, tell me so that I can write it down.
I don't know this is a question, but time the chain will know.
How to answer this question? Do you have a power?
Yes.
Do you have inside also x and something? So once you have a power greater than 1 or different than 1, that's it, it's a chain.
I wrote it because I'm not sure if it's correct.
Me too.
No way. You did well in the quiz, right?
Yeah.
Okay, so tell me your derivative.
Negative 2x over 10 squared.
Guys, why are you always twisting things? Why is negative 2x? It's a product, 2x times this. Can you find the derivative of
Because I did
this?
2 times 100 minus x.
Yeah, why are you switching the order? You started with the derivative of the one which is the second in the product. It's a product rule, do you see? It's a product rule. So yes, Abdurrahman.
It's 2 times 100 minus x to the power of half
So the first part of the derivative expression, 2 times 100.
minus x squared to the power of half.
Yes, and that's it, right?
And then plus
And then plus
2x
mhm,
times half
times half
100 minus x times negative 1.
minus x squared
Plus x squared. So
power
power the power negative half.
and then times what?
Negative 1.
Times
Negative 1.
Negative 2x.
negative
Oh,
2x.
yeah, I forgot the square, that's all.
This, I did 2x times negative 2x. Can I do that?
Yes, if you are not.
I got plus negative 4x times.
Y plus negative 4x. Plus negative, so minus 4x. Let's rearrange it now. At the next step. So here I cannot do anything. I'll keep it as is. Really, this solution is easy. Okay, now as you suggested, 2x times negative 2x will be negative 4x. And if negative 4x multiplied by half,
Negative 2x.
negative 2x. So I basically don't have this anymore, right? I multiplied them. Okay. And then 100 minus x squared to the power of negative 1 over 2. Okay. Good. That's the derivative. What else are we supposed to do at the third step, Mohammed?
We find the zeros for the
Of
f prime of x.
of the derivative. Okay.
Yeah.
So that means that I'm going to equate the derivative function to 0. And to save time, that means that all of this is going to be equal to 0. Now remember, in the unit 2, I told you, don't factor, we will do it later. We will have to do it, it's unavoidable. Now, why? Because you are supposed to solve this is equal to 0. The only way to do it is to factor. Because when you are in factored form, your product will consist of 2 brackets. So you can do what? You can equate each bracket to 0. This way you kind of taking a big equation and break it down into simple parts. Okay? So that's I'm showing you like 2 steps ahead why we are doing this. So that means that to save time, I want to factor it right away, okay, at the next solution line. So what are we factoring? This is the first expression. This is the second expression. So we need to find common factors in both. And you always should start with the constant. So the first constant is 2. So we factor out 2, okay? Now what? You have this expression and this expression.
The least one.
So the least one is what? Is negative half. So we're going to factor out the negative half. Now, this is the common factor, okay? So I do the leftover from these 2 expressions, okay? So Mo, tell me, what is left from the first expression? Which will go here into this bracket.
Also pay attention to that.
Hmm?
Also pay attention to the factor part.
It's going to be 100 minus x squared. It's 100 minus x squared.
Maybe you should be a little bit more stressed to get more from the lesson. So, but I want you to focus now with me so that next time you can do it alone. If you want to factor, look, this from this,
Divide.
you need to divide, right? So, Mo, 2 divided by 2 is 1. So I'm not going to write anything. Now I'm dividing this by this. Do you see that the base is the same?
Everything is the same except this one.
Division rule for the exponential function says if you divide, what do you do to the exponents?
Minus.
So you are dividing this expression by this expression. Right? So since you are dividing them, you subtract the powers. So guys, I'm doing this, as you can see, detailed way once, but because you're going to deal with this kind of expressions all the time. So I will write it as one expression, and you more will tell me what should I write in the exponent. Since I'm subtracting the exponent.
The negative one.
So no, at the top is 1/2, it's positive. So you start with the positive, more.
Okay.
And then you subtract the second exponent. Can you?
This will be 1.
Yes, so minus negative 1/2 is becoming positive. So half plus half is 1, so it becomes 100 minus x squared to the first power, which we are not going to write anymore. This is the leftover. So this is not easy to see. It's unusual because when exponents become negative and so on, you see that it's very weird, right? Like I factored out this, and actually I got the leftover without any exponents here. Okay, so that's the leftover of the first expression. Now, Lila, can you do the second expression? And what about the sign? This is another common mistake, right? Don't forget that they are subtracted. So minus. And that's it, right? Minus x. So I will make this smaller. Okay, so now let me remind you where we are. This is affected expression for the derivative, but we don't have an equation yet. So what is it equal to? 0. Guys, is everything fine? You can hear me and see me?
Yes.
Yes.
Good. So now, we already mentioned this at the beginning. So what are we going to do next? We already equated this to 0. So what are we going to equate to 0 now? The mini equations. So yes, let's use this terminology. So first mini equation. What is the first mini equation, Asil? Tell me
What is the what?
First mini equation. Guys, who understands what I'm talking about? Online.
0 is equal to?
Can you start with the expression first? So that 0 is on the right?
So 2 times 100 x squared to the power of negative half is equal to 0.
Exactly. Asil, did you understand the idea?
Yes, I understand now.
So if you understood, can you tell me now what is the second mini equation?
2, 100 minus x squared.
Why 2?
No, isn't the first part?
You have 2 parts in this equation. This is the first part. We already equated it to 0. You are now left with the second part.
100 minus x squared.
Exactly. So 100 minus, guys, and if you just solve it, why are you waiting? What are you waiting?
Minus x equals 0.
Equals 0. I want you to focus on the first mini equation. The second mini equation, you can figure it out yourselves. So in order, guys, again, this is a very common thing. You will see it a lot in other units as well. That's why I want you to stay with me understanding this, because it's very simple, although it looks scary. In order to solve this equation, let's get rid of the negative exponent. Lila, how should I write down this equation without negative exponent?
2 times, negative 2 times.
2 divided by 1.
Why negative 2? Where did you take the negative from?
From the exponent.
Really?
Yes.
Okay, negative exponent rule. X to the power of negative 2, Lila, is equal to what?
X
1 over x.
1 over x to the power of 2.
Do you see any minus here?
No.
No. So can you go back here and tell me how to write it without the negative exponents?
Square root of 100 minus x.
Exactly. All of this is equal to 0. Now, this is a question which is easy but requires thinking. So you have a fraction which is equal to 0. In the numerator of the fraction, you have a constant. What can you say about the solutions here? You remember we're trying to solve.
Isn't it equal to 0?
No, it's equal to
What is equal to 0? No. Let me simplify this question. Let it be 2 over x equals 0. What can you say about the solution of this equation?
x equals 0. X equals
Yeah, we discussed it before. So are you fine with this? Well, nothing is bothering you?
yeah.
They wanted it.
Undefined.
It's undefined, right? You cannot divide by 0. So it means that generally, if a fraction is equal to 0 and the numerator is a constant, you will never get a solution, right? Because of that.
So it doesn't.
So we are not interested that it's defined or undefined. We just want to say that no solutions are there because we are looking for solutions, right? More, is it? Does it make sense to you, right? No solutions. What about the other mini equation? More. Your suggestions. What kind of equation is it? Lila, why are you shouting out the answers? I asked you. So tell me, it's a quadratic. Okay, can you arrange it in a proper order? Because this is important for mod 5.3. Tell me in the proper order, please.
Oh, x squared minus x plus 100.
Yeah. So, and now use mod 5.3, guys, to give me the zeros, the solutions.
First one is 9.5.
9.51.
And the other one is negative 10.5.
I didn't matter.
10.51.
I feel that it's wrong. I feel that we got the wrong solution. Let's see.
My solutions are the same.
What are they? So, guys, we have a guys online. What solutions did you get?
9.5.
Also 9.5, and the other one
9.5.
You need 10.5.
And the other one's 10.5.
negative or positive.
Negative.
Negative. Okay, let's see. Because okay, I didn't solve this before. I hope that we didn't make a mistake anywhere. So, what can you say about this solution? Why?
Negative.
If you are telling me refuse because it's negative,
Because
you
it's-
lose the communication mark.
The dimensions cannot be negative.
Exactly. This is different, right? Refused.
What did I say? I said the same thing.
No, because you said it's negative.
I think I mentioned it. You can hear me, I think.
I told you sit here. I'll hear everything. But refuse since what is x is so dimensions can't be negative. Dimensions. She wants my dimensions can't be negative.
This makes sense. Because x has
Yes,
to be
you
less-
will write down because it makes sense.
No, I'm saying that x1 being 9.5 makes sense because it's.
I don't know. I mean, I didn't solve it this way. Seriously, I don't know if this is value is correct or not.
This-
Let's
no.
see. Let's see because I know what the area should be. Let's see now.
No, I'm saying logically. Like logically.
Let's see. So, all right, we have completed step 3. Guys, check your notes. What's the step 4?
What's that for?
Mhm.
Intervals.
Intervals. Intervals. Yes, because the algorithm of finding extreme values require the intervals. Now, remember yesterday's lesson, and I'm waiting for your ideas. How can we come up with the intervals here?
Inequality.
Inequality is a good word, Noor. But you saying just the word inequality is not enough, right? I don't know what to do with this. Tell me what kind of inequality, at least. But yes, inequality should be created. Create inequality and explain how you can create it.
Okay, so
We can create it.
Yeah? Tell me inequality first. If you know.
The inequality is a double, and we can create it using the width.
Okay, so the width, yeah, so the width is square root of 100 minus x squared. So what kind of inequality should it be?
Is less than or equal to 0.
Why less? You are okay with the negative width, Noor? You mean greater, right?
Yes.
Okay, now to make it easier, look, we can remove the square root. You know why? Because under the square root, we can have only non-negative expressions. You remember that we cannot square root a negative number, right? So we can switch to the expression 10 minus x squared is greater or equal to 0, okay? Can we solve that now? So, okay, can you solve it, Abdurrahman?
Yes. We're going to put the negative sign on the x squared.
Tell me what to write.
Okay, it's going to be 100.
I don't know why you are doing this. Please keep the variable on the left and the value on the right, because this is the source of mistakes.
Okay, negative x squared. Negative x squared is greater than or equal to negative 100. And then we divide by negative 1 and flip the sign.
So x squared has to be
Less than
100. And then remember, whatever we do to the equation, we can do the same thing to inequality. So how to get the limit for x? Because this is x squared.
square root.
Square root. So if you square root 100, you will get 10 and negative 10. Is negative 10 relevant? No. So that means that x has to be
Less than 10.
okay. But that's not it, right? We have, this is only width. What about length?
2x. Yeah, 2x has to be greater than.
What did I do? 2x has to be also greater than 0, which means that x is greater than 0 or equal. So finally, we want to come up with the interval because algorithm requires interval. What's the interval? More. Formulate the interval.
Okay.
From where to where? Yes, absolutely. From 0 to 10. So step number 5. People online, are you here with me?
Yes.
Yes.
Okay. So step number 5. Nur Gineti, what are we doing at step number 5? Check the algorithm.
I don't know.
You don't know? Yesterday's lesson. Do you have the notes in front of you?
This concept,
Yes, more.
we get the initial equation, you said.
To do what with the initial?
Fucking cos of it, the number.
Yeah, so we are going to sub in something in the initial equation. What is it, what they are going to sub in? So x equals what? What are we going to sub in? More.
Can you go up? I can't see. Well, 9.5.
Everything you need to see is here.
9.5, I think it's 9.5.
9.5, and what else?
Eight.
It's a dimension, we dropped it to
Oh, okay, 0, I think.
0 of the derivative, right? Is doing a of 0. Nur Fahmi is doing a of 10.
I see, does it was 0.
And Mo is doing 8 of 9.51.
Which one am I doing this?
You're doing 10. Guys, quickly. So I need these 3 values.
I see the initial. This is not one.
Equation?
Nice.
You didn't take any notes, right?
No, I didn't.
Here. I don't know, I have a feeling that something is wrong. Tell me, what's the error?
Miss, I got 0.
You got 0, yeah? That's expected.
Is it 15.8?
It's wrong.
No, Miss, I'm 10.
Anyways, they both 0. What did you get? So this is our the part which is interesting.
I got 58.74.
Really?
8.8.
No, this is wrong. The area should be 100, so we have a mistake somewhere.
8.8, huh?
58.
I'm correct.
So there is a mistake because it should be 100.
Allah
I'm
knows.
going to cry.
Who, you? Why?
That's all of this and now it's wrong.
It's okay. It happens. I was solving yesterday. I was solving a different way. I tried to do the one. I saw something like this in the solutions. I think that there might be mistake with the derivative. 2x, and this is width.
It's going to be 2 times this, and then that plus.
Just a second. I have it here. Yes. So
What's that?
this is 2x. This 100 minus. This is the. Where is the area function? I don't see it. Where is the area function? 2x times this, right? Is this what we got? Guys, can you check your notes?
Yes.
Is this our expression of the area?
Yes, just put it in.
2x times 100 minus x squared.
It's x squared.
Okay, then it means that we made a mistake somewhere in the derivative. This is because, can you look? This is the expression they got, but they made a mistake here. This should be x, not y, of course. Can you check if you have got the same for the derivative because you have notes?
No, we don't have that x.
We don't have that x, but
Oh, no, we do.
so can you check all of this? Yes, because we multiplied this 2 by 2 and then squared, right? No, it's squared. Do we have square?
Yes, I need to call check.
Or it's just, no, it should be just 2, right? Because
Yes,
this is, no, this is should be 2x.
This 2x and then.
Do we
on
have
the
this
side-
x there? Do we have, or did we lose it?
Let's check it very well.
Yes, so we lost the square.
Which square?
This square, because when we were multiplying this by this, it should be x should have been squared.
Ah.
Look this.
Yes.
Okay. Did you guys understand the mistake?
Yes.
Let's fix it quickly.
So it's going to be negative 2x squared.
Just a second. So this is the x which we lost, this x, okay? So this is going to be squared. So how is it going to affect us? Let's see. So we factored out 2. We said that here,
It's going to be minus x squared.
just a second. This is, we said only x left, but actually it's squared. Right? As we see?
Yes.
Lila, do you understand the mistakes?
Where are we?
So we lost this x. When we multiplied 2x by 2x, we said that it's 4x. But it should be squared.
Okay.
Okay, so when this expression we were factoring, we took 2 out and this. So this expression has only this one, and this we wrote that it's minus x, but it should be minus x squared, okay? So we need to fix only this part. Where we had, guys online, are you following me?
Yes.
Yes.
So this should be squared, right? This should be squared. So I'm going to erase this part.
So it's negative 2x.
So I'm erasing this part. From here, it's wrong. Okay, so it's going to be 100 minus 2x squared is equal to 0, right? So you don't need mod 5.3 here, right? So you can put negative 2x squared, or you can use mod 5.3 if you want. Is negative 100, right? Then divide by negative 2. So x squared is 50. Yes, now I remember that this is the right thing. And then x is going to be square root of 50. Can you give me the answer? In,
7.07.
no, radical, with the radical.
5 radical 2.
5 radical 2, right? Or 7? 2? Yes, it should be 2. Okay, or negative.
Yes.
But negative,
Already.
we are going to
Dimensions cannot be.
yes. So this one is refused. Will not repeat why, but you will have to, when you solve, you have to explain the detailed way why it's refused, because it's dimension. So now But we also need to know approximately, Noor, what did you say? What's the decimal? 2.9? No.
7.07.
7.07. Okay. So with the, the inequality is fine. There is nothing to be fixed because derivative was not involved there, okay? So we need to only finalize this part. Correct, I mean this part. So this is going to be 7.07. So let's calculate it now. So it's, oh, something is wrong. It
Yes,
has
it's 100.
It's 100, right?
Yes.
7.07. Okay.
Well, it's like 99.9999.
So it's approximately 100. 100 square units because they didn't specify anything. They said units. So it's gonna be 100 squared units. Square units. Square units.
I'll just write as quick.
Okay. Done. Let's do the therefore statement. Noor Fahmi, can you make the therefore statement? Noor
Yes.
Fahmi.
So therefore, the area of the rectangle.
The area of the rectangle, right?
Yes.
Or you mean the area of the largest rectangle, right? The area.
Yeah, the area of the largest rectangle is 100 square units.
Of the largest rectangle.
Honestly, the area of the word inscribed
You don't have, no, not to that extent, but it's important to mention that's not the area of rectangle just, right? Because the question wants us to get the largest one. So the area of the largest rectangle is 100 square units.
I'm just seeing if it's going to be explosive.
Okay, I'm happy that we fixed the mistake.
It's working.
break this.
I'll break, but I don't know.
I want to stop recording and I can't.
That is bad.